It's a great pleasure to welcome all of you to the keynote address of Meliora Weekend. And there are few pleasures quite equal to welcoming back to the University of Rochester our graduate, our former board member, Nobel Prize laureate, Secretary of Energy, Stephen Chu. Before he begins his remarks, it is my signal honor to present him our highest honor, the Hutchinson Award. And let me read from the citation. Dr. Stephen Chu, co-winner of the 1997 Nobel Prize for Physics for developing methods to cool and trap atoms with laser light, was appointed by President Obama as our nation's 12th Secretary of Energy and was sworn into office on January 21, 2009. Dr. Chu is a preeminent scientific leader in the search for solutions to global energy challenges, and as Secretary of Energy is charged with implementing an ambitious agenda to invest in alternative and renewable energy, end our reliance on foreign oil, address the global climate crisis, and create millions of new jobs. Since his undergraduate days at Rochester, his insight, enthusiasm, and gifts for science have been abundantly clear. Dr. Chu has successfully applied techniques he developed in atomic physics to the science of molecular biology. Motivated by his deep interest in climate change, from August 2004 until January 2009, he led the Lawrence Berkeley National Laboratory, where he galvanized scientists to focus on energy security and global climate change, always seeking to bridge the gap between the mission-oriented science and the applied research that leads to energy innovation. As Secretary of Energy, Dr. Chu seeks to foster partnerships with academia and industry, particularly through the Department of Energy's network of national laboratories, where 30,000 scientists and engineers perform cutting-edge research. At a time when energy is so pivotal an issue for the nation and the world, we are indeed fortunate to have this brilliant, resourceful leader in the Department of Energy. We are proud to recognize Stephen Chu for his extraordinary work as a scientist, his enduring commitment to addressing global energy challenges, and his pioneering leadership in alternative and renewable resources for the benefit of society and the preservation of our planet. It is therefore my great honor and the great honor of our chair of the board, Ed Hagem, to present Dr. Stephen Chu with the Charles Force Hutchison and Marjorie Smith Hutchison Medal, awarded to an alumnus or an alumna in recognition of outstanding achievement and notable service to the community, state, or nation. And now, if I can actually find the award. Ladies and gentlemen, Dr. Stephen Chu.
Thank you. Thank you, President Seligman. It's a real honor to be here today, and it's a real thrill to return to the University of Rochester. I attended University of Rochester as an undergraduate from 1966 to 1970. And it was one of the most formative 4 years of my life, and I will always remember Rochester constantly. It's a great school. So I'm here today to talk about meeting the energy and climate change problem. The United States has an opportunity to lead the world in a new industrial revolution. We need a new industrial revolution. The first one gave us countless energy, so much energy if you take the average American home of 4 people and look at the average amount of energy we use in the United States, but convert it to the coin of the realm before the Industrial Revolution. So this coin of the realm would be, 1,000, 2,000 years ago, where if you were a king or a lord, your wealth would be measured in the number of animals or servants you might have. So it takes 2,500 calories per day to feed a person. Every man, woman, and child in the United States has 100 energy servants, 400 energy servants per 4-person family. This is why we enjoy the world we enjoy today, but there are some issues. So we want a new industrial revolution that's a cleaner industrial revolution. We want it because it's going to ensure our future economic competitiveness. It's going to decrease our dependency on foreign oil. We import over 60% of our oil now, hundreds of billions of dollars a year, and we should decrease that dependency. And finally, we need to mitigate climate change. So let me talk especially about the last thing, climate change. This is a record of the temperature of the Earth, starting around 1850 to 2006, and it's the IPCC record. And so it wiggles about, but the overall trend, I think you will agree, is that the globe is warming up. And it's warmed up about 0.7, 0.8 degrees centigrade since the beginning of the Industrial Revolution. Now, it has bumps and wiggles. We don't understand all the bumps and wiggles. And so let me just say that if we add another 2 years, I want to point out that over the last 6, 8 years, the temperature has plateaued. And people have made a pretty big deal out of it. Some people have made a pretty big deal out of it. Let's see if let me talk about this. So in the New York Times, it was reported, the plateau in temperatures has been seized upon by skeptics as evidence that the threat of global warming is overblown. So we're talking about this little bump here. And in fact, George Will, who writes op-ed pieces for the Washington Post, had pointed out shortly after that New York Times article, and he says, actually, what makes skeptics skeptical is the accumulating evidence that theories predicting catastrophe from man-made climate change are impervious to evidence. The theories are unfalsifiable, at least in the short run. And he goes on to say, warnings about cataclysmic warming increase in stridency as evidence of warming becomes more elusive. So now I'm trying to introduce a new concept in Washington, D.C. Instead of writing about things, let's look at the data. Every person is entitled to their own opinion, and they're certainly entitled to say whatever they want, but they're not entitled to their own facts. So now in actual fact, and even before this actually got into the op-ed pieces, you will notice that over a period of maybe 10 years, the temperature does go down. And we do not fully understand a lot of these bumps and wiggles. In fact, I'm doing a little bit on the side of trying to understand some of these bumps and wiggles, but we fundamentally don't understand it. And so it would not be that surprising if this were another plateau, and it could even be a dip. And they last maybe 10, 12 years. But the overall trend is unmistakable. And I also want to point out that if all we had was data from 1880 to 1980, or 1970, there would be very few scientists that says we have an incredible problem. So it's an accumulation over many, many years. And in actual fact, if you look at some of the correlations, I would expect that this would plateau. It could even dip a little bit, and then it will roar back actually much more significantly, but we'll see.